And today we'll be what we'll be looking at, we'll be writing a mini project that will combine what we have been learning in the previous videos and write a simple project that asks for a user the name and then displays the name besides greeting. So let me show you what we'll be doing. So I will just maybe input my name like that, so you can see it has printed my name with a greeting. So this is what we'll be writing. As you can see, you may see that it's a simple project, but it combines most of the things that we have been doing so far. So if you're interested with that, let's get straight into it and write the project from the ground up. So I'll go ahead and use nano as usual. I'll name this project.s. You can name it whatever you want. Then after that, what I will do, now we have to break down the project into small manageable tasks, so to make it easier for us to write the project. So we'll go ahead and write some comments. So as you can remember, comment starts with a semicolon, then what you want to write. So we have to output a prompt message. So the enter name prompt message, so e.g. enter name like that. Then we get the input from the user using the keyboard. So get user input. So get user input. Then again output, put the message or output the greeting with user input. So this is what we will have to achieve in our program today. So let's start with the first section. So as you can we have seen in the previous video, because this is a string, we'll have to declare it on the data section. So section.data like that. So I will name this prompt. Then we want 1 byte, so db means 1 byte. Then what do we want? The message enter name like that, then followed by a comma, followed by a 0. So this means that, or this tells the assembler where our string ends, so for it not to continue reading into some weird memory location. So this is an equivalent of that. So this is an equivalent of a null terminated string, in other terms. So again, we have to calculate the length of our prompt. So I will just name prompt len. Then we want again another byte. We want to use EQU. So remember this trick to calculate the length of a string. So the name, then this symbol over here again, then we use a $, followed by a dash, followed by what, the thing that we want to calculate the length, which is the prompt. So with that, let us try to output the message over here and clear that to do. So again, I will declare my text section. So as you can remember, this is where our source code will reside. Then I just go ahead and declare our starting point, global start, then start like that. Now we'll be moving some registers, some numbers into some registers for the system read protocol. So I will move into EAX the value 4. As you can remember, this stands for system write. So we are telling the machine that we want to write something. Then we move into EBX. So this is the sequence of writing into standard output. So into EBX we want 1. So this means where we want to print to terminal / screen. Then we move to ECX. What are we moving? ECX expects a memory address or a pointer, which is prompt, like that. Then EDX expects the length, so prompt len, like that. After that, don't forget to int 80h. Then let us exit successfully, or gracefully. So EAX1. So this, as you can remember, this was the sys exit. So this is to tell the machine we want to exit. Then into EBX, what are we printing? So this is like a return 0 / status code. So any non-zero number means that there is an error. Then go ahead and interrupt again now to exit. So if you don't put this thing over here, it will result to a segmentation fault, but we have put it either way because we'll have to exit from our program at some particular time. Then let me save it and try compiling it. So nasm elf32 followed by the name of our assembly, then followed by this over here, our object file. So what has happened? Fatal elf32. So I've omitted the -f flag, sorry for that. Then with that, it has generated our object file over here. Then let us go and link it using our linker. So -m elf i386, that, followed by our object file. So it was project.o. Now our binary, which will be project. With that, we have generated our binary over here. So let us try running it to see if the output of the prompt has been shown to the screen. So project. So so what's happening? So there is something that is happening. So I don't know why it's not typing. So something is wrong with my machine. So let me close it and try opening it again. So we'll go ahead, open my terminal. So let us see. There is something in my machine. So I'll cd to my desktop, cd to assembly, so cd to project. So I think there was something wrong with my machine, but let me open now. Let us try running it again. As you can see now, it has shown our output, but now we want the program to give us a leeway to input something from the user. So I'll just use nano again, then open my project source file here. Now next, what we'll do, we'll just read. So get user input. So that's our next to do. So I will move into EAX again, 3. This indicates sys read. I want to read something from the keyboard. Then move into EBX 1 or 0. Yes, this is to tell the computer what we want is to redirect. We want, or you can say the device, which will be keyboard, where we'll be writing our, where the user should use a keyboard to key in the input. Then move into ECX. ECX again expects a pointer. Now, where are we storing what the user has keyed in? Now we introduce another section that we have seen. which is section.bss. So as you can remember, the BSS section is used to declare an initialized data where we reserve some bytes for later use. So I'll go ahead and name a variable called name. Then we use resb to tell the computer we want to reserve some bytes. How many bytes? I'll use 1024. Why 1024? I want to waste memory.
Shut your fucking mouth! No problem, Charles.
Because why not? But I'm joking, I'm being dramatic, but you can use a smaller number like 100, but I'll be using 1024 because I want to waste some memory. Now here we just put what we have declared in the BSS section here. Then we move the size of that memory location, which is 1024, the length. Then with that, we'll interrupt as usual, like that. Then I will save it, and let us try to assemble and link it again and see if it is working as expected. So I'll save, then exit again. So we'll go ahead, so we'll compile it afresh. -f elf32. So we want the .s, then we want to generate an object file, project.o, then link it using elf i386, followed by the object file, which is that. Now we want to generate our binary, which will be that, and let us try running it. So project. So nothing has happened. What has happened? So have we linked it successfully? So let me try. And we have an error here. We have an error over here. So it is elf32 project s project.o, like that. But what has happened? Something is wrong over here. So like that. Now we have an object file. But if let us try to link it. So ld -m elf i386, followed by project.o, then -o our binary, which will be project. So this is our binary. So let us try and run it. So project, something is not working. So let us go to our project.as file and see what we are getting. So this is the system read 0 name, so int 80h. Why are we not getting, I'm sorry, so it's not EBX, it's EDX. So mistakes like this happen, so you should be very keen when writing your code, but this is a normal thing in computer programming. So I had put EBX instead of EDX. So let me save it again and try and compiling it afresh. So like that. Like that. Now let us try running it. So project. So you can see now we are getting a prompt message and the computer expects us to write something. So I'll go ahead and type something like Helen. So nothing happens because we haven't write the instruction now for the output. So which contains hello plus what the user has put into the buffer. So we'll go ahead. Let us go back to our source code and make that happen. So after taking input from the user, we'll just display the message and then display what the user has keyed in. So again, show greeting. So I'll move into EAX4, meaning system read, system write. Then I will move into EBX what 1, the screen, then move into ECX what we want to output, which was output. So if I go over here at the top, you can see we named it, we hadn't declared that variable. So let's go ahead, I name it output. Oh, let me name it greeting. We want a byte of hello to store, then followed by a comma, followed by a 0, meaning this will tell the assembler where our string ends. Then we'll go ahead and get the greeting length, which will be expected inside the EDX register. So this is the trick that we use. Then the name of greeting, like that. So we have now the greeting, so we can go ahead and instead of output, we have named it greeting. So I named, is this the correct way? So let me check exactly. So greeting, it's good. So greeting, so it has to match what exactly you have defined. Then I'll move into EDX greeting len, like that. Then we have to do an interrupt, so int 80h, like that. So this will display hello, but after hello we want it to display now our name. So show user input. So again, this is a system write, so we'll move EAX, the value 4, move EBX, value 1, move ECX, what, the name, where our data resides, which is the name, and it will contain what the user has keyed in. Then move into EDX 1024. So that if you had used the 100, put 100. If you use 10, put 10, but may use 1024. Then I will interrupt with an 80h over here. So with that, now we have now the full program that we need. So we'll do a summary. So first of all, we came in the data section, defined our prompt over here, then null terminated it with a 0 over here. Then we calculated the length of the prompt, stored it in prompt length, then defined our greeting over here. So greeting, we want 1 byte, so db means 1 byte, dw 2 bytes, so on to dd 4 bytes. So but we want a db 1 byte. Defined our greeting, then null terminated it by 0, and I've told you that that 0 means that, or tells the compiler this is the end of our string. Calculated the length of the greeting. Then over here in the BSS section, we defined an initialized data, or a buffer that will be used to store what the user will key in using the keyboard, and you use the name of the variable followed by resb, so resb, resw, so and there is resdd, but we'll be using resb for, we want how many? We want bytes, 1 byte. Then how many bytes do you want? 1024 bytes. Then go ahead, we printed our prompt using this protocol over here. So you put 4 for system write, 1 to redirect it to where to print, to the terminal, the prompt we want it to show, and the length, then an interrupt. Then we took the user input here by putting a 3 into EAX for system read, 0 the device, which is the keyboard, then where to store what the user has keyed in the name buffer over here, the name that we declared in the .bss section, then the length 1024, then we interrupted, then we showed our greeting using the same protocol over here. So is the same. So you put 4, you put 1 into EBX, you put what you want to print, you put the length, then you interrupt. Then over here, now we showed what the user has keyed into the keyboard, again using the system write protocol. So move into EAX, the value for move into EBX1, then name, then the number of bytes, then you interrupt. After that, we have exited our program successfully. So let me save and try and recompile it again. So I'll save and I'll exit, try to assemble it, link it, and run. So I'll put my name. As you can see now, it prints my name with a greeting. So this code I will put it on my GitHub account, where I will put it public for you to access and just go through the source code. But as you can see, it's easy, but it entails a lot of lengthy or bulky source code, but it's worth it because now you have to practice now what we have been doing in the previous videos. And if you have any questions about this project, you can just ask me on the comment section, or I will leave my WhatsApp number over there where you can contact me, so that maybe we can help each other in this learning process. And as you can see that it's a simple project, yes, but it entails so much things that we have done in our previous videos. But as you can see, it's easy, it's a simple project. I urge you to try it on yourselves, so you can write it without looking, or you can try to just solidify what we have learned in this video series. So if this video has been helpful to you, just leave a like, subscribe, and leave a comment. And if you have any question, you can ask it on the comment section. And if you have not turned on the notification bell, so turn it on for you to get notification when I drop my next video. So that was all for this project, and we'll see you on the next video, where we'll be now tackling some more advanced concepts inside assembly. And I will strive to be coming up with some small projects after maybe learning something in a while. Then we can see now the use case of what we have learned in real world scenarios. So thank you for your time, and see you on the next one.